See if it's record. It's, I don't know. Okay, 82. Today's the 26th. And you got this cutout that actually puts everything we've done together over, I guess, the last 3-4 lessons. Because you've got all your rules for parallelograms, rhombi, rectangles, and then squares. And what's the weird thing is squares, parallelograms got all of these, and then we did rectangle, and then rhombus was the easiest, and squares is the super, super, super easy one because it has all the properties of all of these. So it has nothing new. We don't have a new rule. So we like that. And before we glue it in, I'm going to, and you may have already put glue on it, but that's okay. I'm going to circle, if you happen to have a highlighter with you, you do it, but I don't have one handy. I'm going to circle the rule that most people struggle with, and I circled it last year, I circle it every year, is that one right there. Now, it's a rule for parallelograms, so it's a rule for all of them, which for rectangles and squares, it's obvious. But for a parallelogram and for a rhombus, it's not. And it's that the two consecutive corners, like this one plus this one, even when they've got the diagonals drawn, add up to 180. Like this one plus this one add to 180. You know, on a rectangle, 90 plus 90, square, 90 plus 90. So, I mean, it's there, it's obvious, but not obvious. So I would suggest that you highlight that one. Go ahead and glue that in. We're going to do two quick examples, one with angles and one with sides. And then, I say it every time, but you only don't get much, but maybe we'll have a little extra time today. Okay, well, you're doing that. I think there's probably just one square on here, and I think it's probably labeled on your geometer. I mean, it's pretty obvious. Yeah, it's right under that rhombus up there. And go ahead and put the diagonals in it. Now, I'm going to state some facts, but I'm going to add a little information to it as I say it. So you listen to the reason why we can say what we can say on these. Okay, these are by letters. These are not by numbers. So I'm going to have to go, let's see, we're going to call it D, E, F, G, and probably an H right there where they cross. And we're going to do the measure of angle. Now we could do them all, E, F, G, measure of angle. And you'll notice you're not going to be given anything. I mean, you're given a lot, you're given all the rules of a parallelogram, but you're not given any numbers. And the measure of angle DHG. It's a bad one, I can't read my own writing. Now I wonder why we're not given any angles, anything in it. And then we'll do one with segments here in just a second. Why do they not give us any angles? Where? On all the corners, and now remember, it's 90 degrees on all the corners because it's a rectangle. See, I'm going to use those rules for you. But it's a rhombus, and we know that the rhombus has perpendicular, that they're right angles right here too. So you got right angles, and all the corners are right angles. So here's the easy part. You know, you'd think the square with all of these rules would be the hardest. The square only has two answers. They're either going to be 45 degrees or they're going to be 90 degrees. because the other thing is that the diagonals of a rhombus bisect the angles. So we know this angle is the same as that angle, and then we know this angle is the same as that, and we know those angles are equal to each other. So you end up here with 45, 45, 45, 45, all the way around. And that's because it's a rhombus. Right angles because it was a rectangle. Right angle, 45 degrees at the corner because it was a rhombus. And 90 degrees in the center because it's a rhombus. So, what do we need? They're either going to be 90 or they're going to be 45. What's EFG? 90. HDG. HDG. Okay. That's the hardest part, just finding them so you know which one. FEG, there's another 45. And that's the part you got to watch. Make sure you don't label them wrong. And then what's the bottom one? DHG. See, now there's that 90 because it's a rhombus. So see, there's your 90 degrees there. Now let's look at what we know about the segments. So, same picture. Oh. Yes. Oh, you're leaving?
Well, he's not leaving the school. He has to take PSAT today.
Well, get your stuff. Well, I asked him this morning, did he have to take the PSAT? And he said no.
That's okay.
But that's okay.
Yeah.
Probably, but just take all your stuff because you're not going to be back. And you know, I didn't look to see if he was on the list.
I'll explain it on the way.
Okay. Was he on the list?
I think so.
Oh, okay. Well, I apologize.
No, you're fine. Just a few sophomores worth.
Okay. Well, I knew that. And I knew Jackson was. And I checked for him because he wasn't here. And I said, didn't I ask you, did you have to take it? And he said he didn't. So he may not have gotten the email or something. I don't know. No, I don't think it's a big issue. Maybe for him, not for me. Okay, I think you're good on the lesson.
Well, see y'all later.
I guess I'll go cut that out of my video. Okay, so we've got another square. And this one is STUV, and the center is W. And we want, now they do have to give us something. So we're going to say ST is 15. And so we need to find VU, SU, TV, and SW. Now, big hint, because it has right angles in it, you're probably going to have to do the Pythagorean theorem. We have that quite a bit. But what's interesting is now, because I know some of you got rectangles, I say rectangles have right angles in the corner. So when you do a rectangle, it has to be the big halves of the rectangle. If you do the rhombus, it has to be the little one because the right angle is in the center. But see, with this, it can be either one. Because you've got right angles in the corners, you can do these big triangles, these big 45, 45, 90 triangles. We can use a shortcut to that, especially for those of you that have to take the ACT coming up. That's a quick fact. We'll review that in just a minute. Then you can also do these little ones, but they're 45, 45, 90. So you got a lot of rules here you can use. Because it is a rhombus, all the sides are the same. So 15 all the way around. And that's all I'm given. So, do we know VU? Do we know SU? We do not. Do we know TV? We do not, but SU and TV are the same because it's a rectangle. The diagonals are the same. And SW will be half of SU once we get that. And that's because diagonals of a parallelogram bisect each other. So, let's go to the right triangle. Now, you have to decide which one you want. Because we don't know these, we need to use the big corner So I'm going to redraw it, if I can halfway draw it. Ooh, not doing very good a job. I'd probably be better off doing this. Let me just do my square and then split it down the middle like we did when we did 45, 45, 90 triangle. Because there wasn't one on here, I just did half a square and draw it. So I've got S, V, U, and I've got 15 and 15. Now, if you don't remember a 45, 45 triangle, 45, 45, 90, you could do 15 legs squared plus legs squared equals hypotenuse squared. I can call that X. Okay, you can do that. I'm not going to wade through that right now. I will in just a second. But if you remember a 45, 45, 90 triangle, especially this one, because this is the easiest one, do you remember what the rule is to get from the leg to the hypotenuse? Leg to hypotenuse, let me see if I can give you the page number real quick. I think I can get to that because it was right before Christmas. Here it is. 45, 45, 90. If you're going from the leg to the hypotenuse, you multiply by square root of 2. And if you're going from the hypotenuse to the leg, you divide by square root of 2. This is the easiest one. So we're going to multiply by square root of 2. I'm just telling you, you have to do it this way. No, but it's definitely a time saver. So X is equal to 15 square root of 2. But they would like the decimal. So I can just take 15. See if I can get that where you can see it. 15 times the square root, I always punch the wrong one, there we go, of 2, and I'll get in my habit of telling people they need to close the parentheses. I'm bad about not doing it in geometry, and then when you get to algebra 2 and you have to, it's a mess. And then you get 21 point, and the 1's going to make the 2 stay the same. So that's the whole hypotenuse, so that's SU, and that's TV. And how do we get the, well, hold on, let me type that again. 15 times the square root of 2. Okay, now you could take that and divide by 2 because we know these two segments are equal. I like to use, you could take the 21.2, but remember, you have to be careful with your rounding. So I'm going to divide it here, just divided by 2, the whole thing, and I got 10.6, which is what you would have gotten. Sometimes it rounds a little bit different when it's like that. Now, if you don't want to do it that way, it's 225 plus 225 equals x squared. X squared equals 450. Square root, and x equals, and see, square root of 450 simplified would be that 15 square root of 2. So if I do square root, I just cannot tell which key that is because there's two of them that look a lot alike. And 450 should give me the, yeah, there's the 21.2, the same answer. Okay, you've got about 10 minutes, and some of you have corrections. Let me go finish your 37s. Now, 38 is everything. It's everything. So you may have to flip back to your notes to do, and I'm not sure the pictures are drawn on every one of them. So you'll may want to draw some pictures on some of them if you need to.